So here we'll be looking at how to find the product of all factors of a particular number. So once again, we first prime factorize the number capital N into the prime factors and their powers. And so now we'll be studying this particular topic by dividing it into two parts. So first we'll see how to compute the product of all factors in case N is not a perfect square and in case N is a perfect square. So we'll be doing this using examples. So in case N is not a perfect square, let's take an example. Let's take a simple one initially to understand the concept. Let's take N equal to 6. So now what are the factors of this particular number 6? They are 1, 2, 3 and 6. Now we see, as we have to find the product of all these factors, let's call the product as P. So the product in this number would be 1 into 2 into 3 into 6, which is nothing but this 1 into 6 we get a 6 and this 2 into 3 we get another 6. So we get 6 square, and note that the number of factors here is, so from here we see the number of factors is 4. So therefore the product is nothing but 6 raised to power nf upon 2. So this will always be true because whenever we write the factors, that is 1, we will always get a counter factor which when multiplied by 1 will give us the number n. So basically we can always find a pair of numbers whose product is the same number n. So let's take another example to understand this. So now let's take n equal to, let's take it to be 12. So here the factors would be 1, 2, 3, 4, 6 and 12. So now here we can again form the pairs. So this 1 and 12 product will give us 12. This 2 and 6 product will give us 12. And this 3 and 4 product will give us 12. 3 into 4 12, 2 into 6 12, 1 into 12 12. So once again the product will here come out to be 12 raised to power 3, and the number of factors is, so number of factors is clearly 6 here. So which means again we got 12 raised to power nf upon 2. So therefore for any n which is not a perfect square, the product will always come out to be n raised to power nf upon 2, where nf is the total number of factors of that particular capital N. Now why we are saying that it is only true for not a perfect square? Because for a perfect square the number of factors will come out to be odd, as we saw before. So this means nf upon 2 will anyways not be able, we will not be able to compute. So for not a perfect square n, this is valid. The product of all the factors is equal to this. Okay. So now let's look at the case of when n is a perfect square. So let n be 36, which is a perfect square. N is 6 square, which means it is 3 square into 2 square. Now the number of factors here would be 2 plus 1, because the power of 3 is 2, power of 2 is also 2, so 2 plus 1. So the total number of factors we can clearly see are odd here. So why is this number odd? Because one of the factor, so one of factor here is root n, which is 6 in this case. Now we will never get a number to multiply with 6 to get the number itself n. We cannot have 6 twice. Okay, 6 is one factor, but we cannot have 6 twice. So let's write all the factors of the number 36. So they will be 1, 2, 3, 4, 6, 9, then we'll have 12, then 18, and then 36. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 factors. Now let's make pairs. Let's try to make pairs at least. 1 and 36 gives us the product 36. 2 and 18 gives us 36. 3 and 12 gives us 36. 4 and 9 also gives us 36. But we are left with 6 here, which is alone. So what we see is that the product here in case would be 36, which is the number, raised to power 4 into 6. So basically we see that when n is a perfect square, the product of all factors is not n raised to power nf upon 2, but it will be n raised to power nf minus 1 upon 2 into root n. Okay, so basically this could also be written as p equal to n raised to power nf upon 2 minus 1 by 2 into n raised to power 1 by 2, which will again come out to be nf upon 2. So in fact, what we got when n is not a perfect square and n is a perfect square, we have got the same formula, but we have to be careful here because here the nf upon 2 will come out to be in decimal. So we have to have one square root term instead of a factor itself. So these we have to be careful. For a perfect square, the nf upon 2 will come out to be a fraction, in fact a decimal, because nf will be odd in this case. So this is how we compute the product of all factors of a number.